The first Earth Day was celebrated 50 years ago, April 22, 1970. Accidents like the massive 1969 Santa Barbara oil spill and the fire that burned literally on the highly polluted Cuyahoga River in Ohio had raised the public consciousness about the need to protect the environment. Soon afterwards, acid rain would capture the public's attention. However, in the early 1970s, while some scientists had expressed concern about the rising levels of carbon dioxide in the atmosphere, human-driven climate change was not widely recognized nor a topic of national discussion. In 1975, the Ecosystems Center at the Marine Biological Laboratory in Woods Hole was founded to investigate how ecological systems function and how they respond to both natural and human-driven changes. The goal was to use this knowledge to better manage the Earth.
Ecosystems change slowly, so slowly that it can be difficult to measure these changes in just a few years. But over decades, these changes can be profound. That is why it's so important that we have long-term data, taken over decades, at representative sites around the world by generations of scientists. This information, combined with long-term experiments and models, provides the foundation we need to understand past ecosystems, present ecosystems, and the potential future of ecosystems. And future ecosystems are also our future. We rely upon natural systems to purify our water, to provide us with food, to provide us with the fiber we need for clothing and our housing.
For decades, scientists at the Ecosystems Center have been working to understand the function of two ecosystems that now lie at the front lines of climate change: coastal salt marshes and Arctic tundra. Salt marshes are critical coastal ecosystems that lie at the interface between the land and the sea. They help cleanse water carrying fertilizer runoff and sewage, and they buffer the impact of storms on human infrastructure. They serve as nursery grounds for fish and shellfish, and they are important recreational areas. But they were not always valued. In the past, they were often thought of as waste areas and filled and drained to reduce mosquitoes. By the first Earth Day, we had begun to protect salt marshes with stronger regulations.
But while we had begun protecting salt marshes from activities like dredging, there were other challenges facing marshes. Nutrients inputs to the coastal zone were increasing. Sea level, which had been rising very slowly for the last several thousand years, had begun to rise more rapidly. On the first Earth Day, sea level in Boston was nearly several inches lower than it is now. That may seem like a small amount, but it has a dramatic effect on the salt marsh, where only a few inches in elevation leads to a complete change in the plant community. In order to persist, a marsh must maintain its position relative to sea level, and it does this by trapping sediment and building up peat below ground. To better understand how marshes keep up with sea level rise, scientists at the Ecosystems Center, as well as those around the world, are directly measuring many marsh processes. They measure the rate of sediment buildup using fine-scale measurements. They measure changes in marsh area using satellites, and they use sophisticated instruments to calculate the rate that salt marsh plants are building up peat below ground. They also use mathematical modeling to analyze how rising and falling tides mix salty ocean water and fresh river waters through time. The focal site for our Ecosystem Center is the long-term ecological research site at Plum Island, Massachusetts. This is a site of the largest intact salt marsh remaining in New England, and we've been carrying out research there funded by the National Science Foundation for decades. Measurements taken at Plum Island Sound and around the world lead to some troubling conclusions. Marshes seem to have a very limited ability to keep up with sea level rise. Rates of sea level rise are expected to accelerate into the next century, and marshes may not be able to keep up. The rate of sea level rise depends upon decisions made over the next 20 years, but under the most extreme projections, sea level will rise by more than 6 feet by 2100. What does this mean? At Plum Island, our projections suggest that marshes should persist to at least the end of the century, but with substantial amounts of marsh being converted to open water and changes in vegetation. However, not all marshes will be so lucky. Similar long-term measurements and models of Cape Cod marshes by MBL scientists suggest they will not be able to keep up with sea level rise and that they will be lost. But there are steps that can be taken. Scientists and managers are studying ways to restore marsh in areas where they were lost previously through diking and drainage. We're also trying to determine if adding sediment to marshes will help them better keep up with rising sea levels. We need to remove coastal barriers that prevent marshes from migrating inland. If we can take these actions, and if we start now to control our emissions of carbon dioxide to the atmosphere, we can preserve these marshes for our children and our grandchildren to enjoy.
While salt marsh researchers at the Ecosystems Center study rising seas, their colleagues at the Arctic Long-Term Ecological Research Site, also funded by the National Science Foundation, have been watching firsthand how decades of warming temperatures impact polar regions. In the mid-1970s, ecosystem scientist John Hobby and his collaborators established a research site at Toolik Lake on the north slope of Alaska. The goal was to study the ecology of Arctic tundra, streams, and lakes through long-term monitoring, coupled with experiments and mathematical models. As the decades went by, the gradual warming of polar regions became apparent. While some of the effects of warming were expected, there have been some surprises.
One of the defining characteristics of Arctic tundra is continuous permafrost, a layer of frozen ground that can be hundreds of meters thick. This layer of frozen ground lies beneath a 20 to 100 centimeter layer of active soil that thaws every summer and supports the variety of plant, animal, and microbial life characteristic of the tundra. Because it is permanently frozen, the permafrost serves as the bedrock underlying and physically supporting many Arctic landscapes. As the climate has warmed on the North Slope, the seasonally thawed layer has become thicker, penetrating into the once permanently frozen soil and compromising the integrity of this permafrost bedrock. In hilly areas, this loss of permafrost integrity can result in thermokarst slumping of the hill slopes and a slow oozing of surface soil, peat, and tundra vegetation downslope into streams and lakes, disturbing the ecology of both the terrestrial and aquatic components of the tundra. In addition to disturbing the local ecology, permafrost thaw can also have global implications. The organic matter frozen in permafrost holds about twice as much carbon as the atmosphere, most of it near the surface. Just like the observed reduction in Arctic sea ice, projections suggest that the areas with permafrost will shrink dramatically as the Arctic warms. As permafrost thaws and this carbon in deep freeze storage becomes biologically active, the carbon can be released to the atmosphere by microbial activity as carbon dioxide and methane, a very potent greenhouse gas. Thus, as the permafrost thaws, it releases greenhouse gases, exacerbating global warming and accelerating further permafrost thaw, a classic self-sustaining cycle.
Warming in the Arctic has led to another big change for the north slope of Alaska. Thunderstorms and lightning strikes were rare 50 years ago, but they are now common. In 2007, a lightning strike started a giant wildfire that burned over 1,000 square kilometers of Alaskan Arctic tundra, releasing an unprecedented 8 million tons of carbon dioxide into the atmosphere. Satellite images indicate that the surface recovered its green vegetation within about 5 years. However, this recovery is only skin deep. Modeling by Ecosystems Center scientists suggests that carbon and nutrients lost from the soil during the fire will take millennia to recover.
Although the prospect of climate change for the North Slope of Alaska and the rest of the world are scary, they are beginning to be recognized and widely acknowledged. Climate-friendly energy sources are being developed and are economically competitive. The role of ecosystems in regulating the global climate is becoming better understood, and people, especially young people, are speaking out and demanding climate-friendly policies of their governments. The door on climate mitigation is closing, but it is not yet closed. With all of our efforts, we can reverse climate change and save the permafrost that underlies and defines the tundra. We can stop climate warming in high latitudes and bring back conditions less conducive to convective storms and the lightning-ignited wildfires on the North Slope.
How can you find information you can trust and learn what people are doing, what you can do to help mitigate and adapt to changes in the environment? 20 years after the first Earth Day in 1990, the Global Change Research Act was passed by the U.S. Congress. The act mandated that what is learned about climate change and what we can do with that information be made available to everyone in an ongoing National Climate Assessment Report. The fourth report was produced in 2018 and is available on the web. It's very easy to explore. The information in it empowers us to understand from the experts what is happening, and you can learn about what is being done to help mitigate and adapt to climate change all over the country. There are many topics to look at in the chapters. You might be interested in water, energy supply, oceans, agriculture, air quality, or human health. And to learn about any of these national topics, you can click on the subject, scroll to find the summary, and get many more details and references if you want to deeply explore the subject. And no matter where you live in the United States, you can find information about what is happening in your region. Here in the Northeast, you may wonder about changing seasons, coastal economies, urban areas, threats to human health, and adaptation strategies that are underway. For example, in this video, we've already seen research conducted by generations of scientists studying changes in salt marshes in the Northeast. For Alaska, you can, as another example, find tribal adaptation planning efforts. Or, for the Midwest, you can see new conservation strategies for agriculture to reduce the impact of more heavy rains expected as part of climate change. These reports draw on information from hundreds of experts outside and within the U.S. government, and they are extensively reviewed by the public and the scientific community. Earth Day 1970 was a defining moment for the Ecosystems Center's distinguished scientist Jerry Melillo, who later served leading roles in the development and publication of the first 3 national climate assessments. In 1970, he was teaching high school biology in Connecticut when an Earth Day rally and a public lecture series on issues in the environmental crisis cemented for Melillo that he would dedicate his life's work to understanding the impacts of human activities on the biosphere. 50 years after that first Earth Day, newly inspired young scientists are working toward understanding and mitigating those impacts through the MBL's Semester in Environmental Science, in the Ecosystems Center's laboratories, and in the field.